Hello, my name is Marco Machito from Siama Systems, and today I'll be showing you how to perform a service activation test from a Prova to a smart loopback device on the remote end. You can see in the diagram a very typical application for our solution. The Prova would be connected to an ENNI. It could be physically, it could be through a virtual tap, and it would generate synthetic traffic towards the Uni for the purposes of validating throughput and performance and performing a service activation test to make sure that that service conforms to the service level specification. You don't have to have a Prova on both ends of the circuit. The Prova is suited for a POP site central office co-location facility where you have physical access to that ENNI, and you can generate that synthetic traffic to the remote end where you can locate a NID. A NID stands for Network Interface Device, and there are plenty of Ethernet NIDs on the market that support Smart Loopback. A Smart Loopback takes the frames that it receives on its WAN interface, swaps the MAC source and destination address, recalculates the FCS, and sends it back towards the Prova. So this way we can perform what's called a single-ended test. So the traffic generator and the traffic collector is on a single end, that end being the Prova end. The NID simply acts as a loopback device. There's a second type of smart loopback called Latching Loopback. Now, Latching Loopback is an industry standard loopback defined by the MEF forum under MEF 46 specification. So you can look that up. It's public information. You can download the MEF 46 specification if you want to read up on Latching Loopback. But essentially what it does is it defines an industry standard control protocol that allows the Prova to send a request to the NID to loop back a particular frame set. So we can loop back the set of frames, for example, that correspond to a particular OVC in this use case. So that allows us to interoperate with third-party vendors. So let's go ahead and perform an Ethernet service activation test between the Prova and the remote NID. Now you can see here I instantiated a Y.1564 test suite called Marco Suite with 3 services, and those services have a bandwidth profile associated with each of them. Remember how we were always concerned about manually typing in the remote destination MAC address so we can direct the unicast synthetic traffic to the appropriate device? Well, we don't have to worry about this anymore because Latching Loopback has an auto discovery feature already built in. So it's going to go ahead and it's going to use SOAM PDUs to communicate with Latching Loopback devices in the field, and it's going to auto discover MAC address, so on and so forth. So without getting into the details of MEF 46, you just really need to know that there is a controller end, in this case the Prova, and a responder end, in this case the remote NID. And the controller end is responsible for initiating the loopback and collecting the information, the data, to be presented to the user once the test is complete. So the Prova here is the controller end, and you can see here if I click on controller, that means you have to enable it as a controller. So make sure the controller is enabled, and then it's using SOAM PDUs. So it has the domain and the MEL have to be the same on the controller as it is on the responder NID. So in this case, by default, it's set to SAT and MEL MEG level 7. As you establish loopback sessions, they'll appear here in this table, and you can actually see the PDUs going between controller and responder in this set of statistics here on the upper right hand corner of the screen. So I'm going to go ahead and initiate this test suite. And if we just simply click the play button, you'll see here that it's gonna loop back the device and our remote destination MAC address was automatically discovered, right? And you can see here it's going to run through the CIR test, EIR test for each of the services. And if we want to click on details, you can see here running through the different services. And then it's going to go from the configuration test to the performance test, and we'll be able to export a report. Now that our SAT test has completed, you can go to the SAT controller screen to see that a loopback session was created for each of the OVCs that we wanted to test. If you go back to the suite and click the up arrow, you can download a PDF report of the test results. And in that report, you can see that we ran through each of the services and performed the configuration test and a performance test and went ahead and produced this report. So great. So now that I've shown you how to configure and run a single-ended service activation test, I'd like to discuss dual-ended service activation testing. A dual-ended service activation testing is a little bit more complex to set up, but it offers two major benefits. Single-ended testing only would allow us to measure the round-trip delay. With a dual-ended test, we're able to measure one-way delay, so the delay from the A end to the Z end, and the delay from the Z end to the A end. The second major benefit is that with a single-ended test, we could make sure the bandwidth profiles were applied properly, but if we determined that it wasn't being applied properly, we couldn't tell whether the policer at the ENNI or the policer at the uni was misbehaving. We just knew one of them was misbehaving. With a dual-ended test, you're able to specifically understand whether the bandwidth profile applied to the ENNI is correct and whether that applied to the uni is correct. So those are the two major advantages of dual-ended testing. However, dual-ended testing is more complicated to set up. Like I said, you need a prova on either end of the link of the circuit, and they both need to be synchronized very accurately to some reference clock. In this demo, we have an NTP master clock that we'll sync up to. We are back at the Y.1564 screen on the local end prova that's been deployed at the ENNI. Instead of conducting a single-ended test to a NID in loopback mode at the remote end, what we want to do now is perform a dual-ended test. So we've gone ahead and we've deployed a second prova in place of the NID at the uni. The first thing you need to do is make sure that that prova is being set for SAT mode for the port that's being used for the test. So in this case it's port number 1 and we have it set to SAT. The second thing you need to do is click SAT responder and make sure that the responder function has been enabled. The local end prova implements a proprietary protocol that will go out and discover the remote end prova at the uni. It's going to configure it for the service activation test. It'll coordinate the execution of the test, pull the test results, and then produce a SAT report. So all the configuration is done from the local end prova, and really there's just a minimal configuration that needs to be done at the remote end. So now we simply need to set up the test suite at the local end prova. So we change the measurement from single-ended to a dual-ended measurement, and we'll be measuring bidirectionally. That means from the prova at the ENNI to the prova at the uni, and from the prova at the uni to the prova at the ENNI. So two one-way tests. And by default, remote discovery of that prova at the uni is enabled. So we'll go ahead and apply these changes, and we'll execute the test. Now that the SAT test is completed, we can see that there are results for the forward and backward direction. If you click on the details, for the CIR, EIR, and performance tests, you can see independent results in F for forward, B for backward direction for each of the services. I hope this video has helped you. If you have any questions at all, please feel free to email us at support@siamasystems.com.